Hello, I'm Paul Beckwith, and I'm continuing my discussion on these slides that my colleague Peter Carter put together on how all of the all of the metrics of climate change, things like rising amounts of greenhouse gases, both CO2 and methane and nitrous oxide. And if you combine all those together, you get a CO2 equivalent. So you get a global climate index. And how all those things are tracking the worst case scenario modeled by the Intergovernmental Panel on Climate Change, the RCP, Representative Concentration Pathway 8.5. And then if you look at the impacts on the Earth in terms of the rising global average temperature, the rising temperatures on the land, the rising temperature on the ocean, not just at the surface, but down to great depths, exacerbation of the lowering of pH, the acidification of the ocean, the huge amount of heat that's being absorbed into the oceans. About 93% of the heat that's staying absorbed onto the Earth's surface is in the oceans, and also the dissolved oxygen concentration plummeting in the oceans. And I'll also be talking about the ramifications on extreme weather events and how all of this, like putting together, this is a sort of big picture, looking at the big picture of all the different components and how they're really tracking much worse than the modeling that we've done. Lately, I've tried to have two books on the go, a fiction and a nonfiction. So the nonfiction book, I'm about halfway through. It's by Maria Konnikova. It's called The Biggest Bluff: How I Learned to Pay Attention, Master Myself, and Win. So she's a psychologist and also a writer, and she's always trying to figure out what makes people click, how they think, how they self-sabotage themselves, in a lot of life situations. So she basically studied what it would take she analyzed a bunch of different games. And chess is almost perfect knowledge, right? You don't know how your opponent is going to play, what their preferences are, but it's perfect knowledge. You're not throwing dice and there's no cards involved or anything. Whereas roulette at the casino is almost perfect non-knowledge. It's just total luck. And there's a lot of skill in duplicate bridge and also in backgammon. And I play all those games, but I've never played poker, and this is all about the biggest bluff, how to read people. Like what I do with climate change is pattern recognition, recognizing how the system is changing and trying to determine how the system, where it's going, how fast, where we're going to end up, and the consequences and ramifications to the human population, on also the whole biosphere, in fact. And poker is pattern recognition of not just the cards and the probabilities, the math, but it's also the getting a read on people, understanding pattern recognition in people, how they're going to react in certain situations. So it's fascinating. I'm not sure I'll take up poker, but maybe play a little bit online, just try it out. I'm good at all of these other games. People have told me I should try poker. And this book here, Stephen King, The Dark Half, this is about the 16th or 17th Stephen King book I've read during the pandemic, and it's very, very enjoyable. I'm still loving the King books. Okay, so getting back to the Peter Carter presentation. And we're on slide 11, and here we go. So this is it's the 2021 Climate Change Science Earth Catastrophe Warning to the World. I talked a lot about how you can access this. You can just Google Climate Emergency Institute, and it's there. I show you how to get there in the last video. Okay, so we're on these high risk. We've got a high risk of continuing to follow these worst case scenarios, and then we'll get tremendous heating. And it's hard to see how society could survive. I mean, at 7.8, forget it. I mean, who knows what the threshold is, okay? So A lot of stuff from the UN. Here was a flagship study from the WMO, World Meteorological Organization. They collect data from all over, and they do sort of a state of the climate, state of the planet, and they document the physical signs of climate change, like increasing land and ocean heat, accelerating sea level rise and melting ice, and the knock-on effects on socioeconomic development, human health, migration and displacement, food security, land and marine ecosystems. And, I've always said that food is the biggest problem that we're going to have in the near term from abrupt climate change. So the global survival scenario: climate change is an existential threat to most life on the planet, including particularly humankind. And this was said by the UN Secretary General in May 2015 at the Austria World Summit. Okay, so this data is looking at, these slides are looking at data set trends. Okay, so, and often they're from the Intergovernmental Panel on Climate Change, they're underestimates, but they give us something to go on. All of the projections are calculated from a single climate sensitivity metric of 3 degrees. So if you double the CO2 on the planet from pre-industrial, so from, roughly 280 parts per million to 560 parts per million, we would expect a rise, according to the models, of 3 degrees Celsius. But there's many research papers that are finding a much higher sensitivity than that. Okay, so for a chance of 1.5 or 2 degrees by 2100, global emissions have to go into rapid decline in and from 2020, but current policies are for an increase. So here's a couple plots. This is from the UNEP, United Nations Environmental Program 2020 Emissions Gap Report. And it shows here we are at 2020 and the different ranges, temperature ranges, and the amount of emissions that we would have to slash to go down to go down in those regions. So basically following these different this is the current policy scenario. This is to maintain 2 degrees. We have to have a huge drop in emissions and even larger to go down to the lower temperatures. And even those only give a 2/3 or 66% chance of success. So that's not happening. We're trending right up here, current policy scenario, to a world of grief. Now, how are different countries doing? These grayish grayed countries are critically insufficient. Planetary catastrophe will result. And then highly insufficient is the red, insufficient is the brown. The yellow countries are compatible to 2 degrees Celsius only by 2100, and the 1.5 degrees Celsius Paris Agreement compatible, there's only 2 countries, Morocco and Gambia. That's it. Okay, the pledges and targets are for 2.8 degrees Celsius, but current policies are even above that. So, 3 degrees Celsius up to 4.1 degrees Celsius. So all of the science published recently talks about the, we're worst case scenarios, climate's happening faster than expected. Like here's this study on global temperature in 2020 that was released in mid-January from NASA Goddard Institute of Space Science, GISS, Climate Expert Group. They found global surface temperature in 2020 was in a virtual dead heat with 2016 for the warmest year. 2016 was a powerful El Nino. We had a weak La Nina last year, which should have cooled the planet a bit, but we still we still had a virtual dead heat with the previous record. In fact, we set most studies show that we exceeded the previous record, so we set a new record. The 2020 global temperature was 1.3 Celsius warmer than the 1880 to 1920 base period. Converting this to set the baseline of 1750, you need to add 0.3 degrees, so 1.6 degrees Celsius. We've exceeded 1.5 already. But most of these discussions nowadays, they talk about this baseline, which I still think is cheating. The 6 warmest years in the GISS record all occur in the past 6 years, and the 10 warmest years are all in the 21st century. Growth rates of all the greenhouse gases driving global warming are increasing, not declining. You know, the Northern Hemisphere had its hottest summer on record, according to NOAA. Cumulative CO2 emissions are tracking the worst case scenario. This paper here, basically we're tracking RCP 8.5 is what is tracking. This is the worst case scenario from the IPCC. There was a paper talking about a so-called pattern effect, which I'll discuss in subsequent video. Arctic is going crazy, right? Worst case scenarios. We're undergoing abrupt Arctic climate change, okay? That's what they're even saying in this Nature in July 29th, 2020 paper, Past Perspectives on the Present Era of Abrupt Arctic Climate Change. We're experiencing an abrupt climate change in the Arctic. Climate models continue to underestimate this warming. Arctic heating is far faster than anybody had anticipated, except for Beckwith, of course. I anticipated it. And the ice record suggests this has happened before. You know, the ice sheet melting for sea level rise is tracking worst case scenarios. Greenland and Antarctic ice sheets have enough frozen water to lift oceans 65 meters, and they're tracking the UN's worst case scenarios of sea level rise. Okay, there were episodes of Greenland warming where temperatures rose 10 or 12 or even up to 16 degrees Celsius in one case over a time frame of decades. From the ice core records, more than 20 abrupt periods of warming known as Dansgaard-Oshur events, and I talked about a couple of very interesting ones where the Arctic became fresh water. Cumulative CO2 is tracking the very worst case scenario. So here's the CO2. Not only are the emissions consistent with RCP 8.5 in close agreement with the total cumulative CO2 emissions, it's within 1% agreement, but RCP 8.5 is also the best match out to mid-century under current and stated policies with still highly plausible levels of CO2 emissions in 2100. So here's 2020, this is historical, this is the observed, and this is the RCP 8.5. This is RCP 8.5 in 2030 and 2050. So we're tracking those sort of things, which is the worst case situation. Cumulative fossil fuel with atmospheric CO2 increase. This is in petagrams of carbon or billion tons of carbon, and we're just heading up, to the stratosphere. Okay, so CO2 emissions, again, they're tracking the worst case scenario. So this is the total fossil fuel combustion CO2 emissions here. The black line is the trend, and these are all the different scenarios. So in this case, we're not right at the RCP 8.5. We're about halfway between that and 6. But then if you look at total CO2 emissions, so this includes land use change, etc., we're much closer to the RCP 8.5 line. So we're tracking the worst case scenario, the RCP 8.5. We're just below it here. Governments promoted a rapid rebound in CO2 emissions in 2020. So basically, when we had the shutdowns from the coronavirus, this is a 2019 curve, week number of the year. So this is 2019 and this is 2020. Okay, so you can see the dips. 2020 was lower than 2019 by about 6.4% because of the world shutdowns from the virus, but it's still tracking up and it's actually recovering. But, we had a little bit of a breathing room there for 1 year, but it's going to be, emissions just came right back up again. There was huge amount of fossil fuels, of public money. This is public money that went into energy in recovery packages. 30 major economies pledged $271 billion to fossil fuels. That's 46% of all public money committed to energy-intensive sectors. So here you go. Still mostly fossil fuels. There was 36% clean energy, 18% other. This is updated 27th of January, 2021. It's on the website energypolicytracker.org. So most of the subsidies to get economies rolling again after the shutdowns due to the coronavirus have gone back into fossil fuels, exactly what we don't need. Okay, I'm going to have another video to finish this off. Thank you for listening thus far.